Memory chip design is the first step in the production of Micron's memory chips. This process involves the use of computer-aided design tools to lay out billions of electronic components that store data on the chip according to the product design specification. During technology development, specific process steps are defined and integrated into a process flow that will build the memory chips. The process steps are tested and refined until the process node is qualified and ramped in manufacturing. Individual memory chips, or die, are built upon pure silicon wafers in a fabrication area, or fab. Fabs are state-of-the-art clean rooms that are 100 times cleaner than a hospital operating room to ensure silicon wafers are protected from ambient contamination. Among the many process areas in a fab, the photolithography area coats wafers with a photoresistant material. Then, like film in a camera, circuit patterns are exposed and excess material is rinsed away. The paths in these circuits are 5,000 times narrower than a human hair. Wafers are moved between different tools and processes using a robotic automated material handling system, or AMHS. Each wafer may be moved through more than 1,000 processes. It takes more than 1 month to make a memory chip. In probe, initial functionality tests are performed on each die on the wafer. A probe card positions probe needles onto each die to send and receive test data. This information is used to generate a map of all the die on each wafer. Only good die that pass all tests in probe will continue through the manufacturing process. In assembly, wafers are first thinned, attached to an adhesive backing, and then diced into individual die using a diamond-edge saw. Using the wafer map that was created in probe, individual die are picked from the wafer, then placed on a circuit board. A solid gold wire is used to connect each chip to the circuit board. A molding process encapsulates each die in a protective plastic package and shipped to test. Every memory chip Micron manufactures undergoes hundreds of tests to ensure it meets the highest quality standards. Proprietary Ambix testers subject finished parts to extreme temperatures and conditions to force any weak components to fail before they reach our customers. Additional test equipment verifies that each part meets or exceeds its speed and performance specifications. All qualified parts are laser marked with part numbers and other identifying information. Each memory chip is optically scanned to verify strict fit and form specifications. Components are placed into industry-standard anti-static packaging and placed into boxes for shipment. Many of Micron's finished parts are used to build memory modules and solid-state drives. Automated surface mount assembly equipment is used to mount memory and other components to printed circuit boards. All products are tested using proprietary Micron memory module and SSD test equipment. Finished products are placed into anti-static packaging before boxing for shipment to the customer.